Alrighty, let's go ahead and get this started. So rational zeros, what does all this stuff mean? Recall that a polynomial function of degree n can have at most n real zeros. So that's kind of like what we do all the time. Every time we try factoring something, at the last step, we check the degree. Just if it's a 4 degree, we should have 4 solutions, 4 zeros. So that's all it's telling us. So that's just something we already know. Real zeros can be rational or irrational, which rational is the main one we're going to be focusing on today. But you can get occasional zeros that are something like 2 root 2 or something like that, something that has a radical. All right, now we have a formula here of P over Q. So what does that mean? It's a little bit confusing. I'm going to come up with a little bit of an easier way of doing this, and we're just going to go ahead and take the factors of the last number. So don't worry about the P and the Q. Focus on the last and the first. So factors, the numbers that you use to multiply to get that number, and that's going to be your last number. A to the 0 means the term with the 0 power, right? And that's always the last one. Again, when we count down to 0. Factors of the leading coefficient, that means the first number. So if it's a 5-degree polynomial, then the number is 5, the fifth term, or again, just the highest term in the whole thing. Let's go ahead and get our list of possible rational zeros. So list all of the possible rational zeros for each function. So again, don't forget, it's just going to be a simple matter of last over first. So the last number we have in this polynomial is 2. So think of all the numbers that multiply to 2. So 1 and 2. Well, not a really big list. Okay, so this is one of those examples that's not a really good example because it's too simple to be a pattern and you can't really get a pattern from it. So there you go. 1 and 2 will be our top numbers. And then our first term here, it's going to be a 1. So we only have a 1. So that means the only bottom number we have is 1. Okay, now we're going to have to get the plus and the minus of this. Now you don't need to circle this. Don't circle this because in all my other classes, I got people erasing them. But I'm just showing you where I'm getting this first one. So it's 1 over 1, which just 1 divided by 1 is 1. So there you go. Now, some of these can have negatives as well. Like if you look at the next one here, you can see that there's a negative number here. So you can have a positive or a negative 1. And now we're going to move over to the next top number, which is 2. And our bottom number is 1. So it's going to be 2 over 1. But again, if you reduce it, it's just going to be 2 because 2 divided by 1 is 2. Go ahead and we're going to box that up. Now we're going to go ahead and get to the next one. So we're done with that one. Like I said, a very short example. Doesn't really give a whole lot to tell what's going on. But let's go ahead and move on. So some of these other examples are a little bit better. So we got 18 here. I'm going to make a list of the numbers that multiply to 18. So 1 times 18, 2 times 9, 3 times 6. 4 and 5 don't work out, so that means I got a complete list. So that's going to be our top number. The last number is 18. So let's make a list. 1, 2, 3, 6, 9, and 18. Our first number and our leading coefficient is going to be 1. So that's going to just be 1. So it's going to basically be like 1 divided by 1, 2 divided by 1, 3 divided by 1. And actually, that is one of the properties, like as a freshman, that's one of the first things you learn is the properties of real numbers. And that is anything divided by 1 is 1, and that's called the identity property. So we're going to get all of these numbers, and I'm just going to kind of rewrite them all here. Right, just positive and negative 1, positive and negative 2, positive and negative 3, positive and negative 6, positive and negative 9, positive and negative 18. So those are all of the numbers that we can use to multiply to get this. And the number of possibilities, it's going to be double that. So there's actually 12 different numbers that we can use to get this, 12 different numbers that we can get from here. Okay, so again, we're just going to focus on this for the first part of the lesson. just getting the factors, listing out the possible factors, and I'll explain why and how you use them in a minute. But let's do a couple more of these here. So let's move on over to the next one here. So our last number is 1. So I'm going to make a fraction with our top number as 1. And again, it's just L over F, kind of like the way we have life method. That's another easy way to remember that. So think of the numbers that multiply to 4 now for our bottom numbers. So 1 times 4 and 2 times 2. Now, if you get a double, you don't need the double, okay? So the doubles, in fact, the whole thing we're trying to get today is avoiding doubles. We don't want extras in there. Okay, so let's go ahead and we only have one top number, so they're all going to have to share. So first one is going to be 1 over 1. And the next one is going to be 1 over 2 and 1 over 4. So again, sharing the bottom number. Hello? Hello? Okay. Bye. You have your phone down. You get it to the front of us. All right, and then we're done with that one here. But again, so, this one here would have been the next one, and then this one here for the last one. So there's about 6 possibilities. So that's also telling you sometimes they can be fractions. All right, sometimes you get fraction results. So just thinking of all the factoring we've done, yeah, there's going to be some fractions in there. All right, moving right along. Now, you can write the list out like I was telling you, make a list of all the factors. But for me, I can kind of do it in my head. So just to keep things moving along, I'm going to go ahead and just start 1, 2, 4, 8, and 16. So 1 times 16, 2 times 8, and 4 times 4, which again, we do have a duplicate, and we don't want extras if we can help it. Okay, so now we also have a different first number. We have 3 now, so it's going to be 1 and 3. Again, you're thinking of the numbers that multiply to get you that number. So that would be, let's see, 1 over 1, 2 over 1, 4 over 1, 8 over 1, and 16 over 1, which again, those are all just going to become the whole numbers of each of those numbers. So let's just write those numbers with a plus and a minus on each of them. So again, 1, 2, 4, 8, and 16. So those are all the numbers that we can do. All right, now we're getting some where we have multiple top numbers and multiple bottom numbers. So we did all of them. So go by the bottom number. Make sure you go by the bottom number, do all of the top numbers, and then move to the next bottom number. So now we're going to look at the bottom number of 3. So 1 over 3. And again, don't forget, it's going to have a plus and a minus. 2 over 3. 4 over 3. And again, I'm just moving with all of the top numbers. And we want to make sure each top number is paired with every bottom number. You could probably do this in multiple ways, but I think my way is the best because it'll put the most common zeros first. All right, there you go. So that's 8 over 3. And now we're going to have 16 over 3. Which none of these, with fractions, anytime you got fractions, look them over. Look for anything that can divide. Like if we had like something like 16 over 4, you can divide that. If you had something like, I don't know, 8 over 4, you can divide that as well. If you have something that doesn't divide, like say 6 over 8, right? You can reduce those just like you would simplify any other fraction. Okay, so that's all of the ones we have here. There you go. And now we're going to get into some of the more common ones that we're going to be seeing. So you're going to probably see stuff like this, maybe a few like that. But again, these are kind of simple. Let's move on over to what we got going on here. So again, last over first, L over F. All right, think of all the numbers that multiply to 12. So again, we want all the factors of 12. Let's see, 3 times 4. 2 times 6, 1 times 12. And again, if it helps out, you can write out the factor list the way you always done it. Like maybe, I don't know, I was in sixth grade when I learned that. So it'd probably be about the same for you as well. So sixth or seventh grade at least, make a list of all the numbers that multiply to whatever you're looking for. Okay, bottom numbers, 1, 2, 3, 6. So again, all the numbers that multiply to 6, 1 times 6 and 2 times 3. So there's not really, well, I mean, that's probably more than we've had in some of these, right? 4 bottom numbers. Okay, now here's where it starts getting a little bit tricky because, again, we're trying to avoid numbers that we already have one of. So we're trying to avoid extras or duplicates. Okay, so the first one again, it's going to be all the numbers over 1. And that's always going to be possibility. It's always going to be the whole numbers of each of your last terms. All right, so there you go. 1, 2, 3, 4, 6, and 12. All of those numbers along with their positive and their negative. Okay. All right, now here's where it starts getting a little bit tricky. We're going to get different bottom numbers now. So now we're moving to the next bottom number. So we're looking at all of these numbers over 2. So our first one is going to be 1 over 2. And just like some of the other ones before, we also get some that will become fractions. So this is going to be a fraction here. And let's go ahead and go on over to the next one here. We got 2 over 2. Do we already have a 2 over 2? Well, yeah, we do. Because 2 over 2 is 1, and we already have a 1. All right, so we're going to skip that. Again, we're trying to avoid ones where we get the same one. How about 3 over 2? Okay, we don't have one of those, so let's add it to the list. 3 over 2. How about a 4 over 2? Yeah, we got a 4 over 2, right? That's the same thing as just saying 2. So we're going to skip that. 4 over 2, we already got one. How about 6 over 2? Okay, yeah, you're getting it now. That's just the same thing as 3. So we don't need to put that down. Let's go to 12 over 2. Yeah, that would just be 6. So yeah, we already got that one. So that's it. We got all the numbers over 2, and we only got 2 factors out of that. We only got 2 fractions. So let's go ahead and move on to the next bottom number. That'd be 3. So 1 over 3. Again, we don't have that. I mean, I can see that we already have some numbers that are fractions, but they don't have a 3 on bottom. So 1 over 3. All right, how about 2 over 3? Do we have a 2 over 3? No, we don't. We don't have a 2 over 3. We have a 3 over 2, but not a 2 over 3. So let's put that in there. All right. 3 over 3. Yeah, that'd just be a 1. 4 over 3. No, don't have one of those. 4 over 3. 6 over 3. Yeah, we do. How about 12 over 3? Right, that's just the same thing as 4. Okay, good. You guys are getting it. Now we're gonna do the same thing with 6. Let's see. 1 over 6. Okay, we definitely don't have a 1 over 6, right? Because just looking at all our bottom numbers, we don't have any of them with bottom numbers of 6. How about a 2 over 6? Do we have one of those? Yeah, we do. Now, just a quick reminder, what am I talking about? 2 over 6. Getting ahead of myself. But yeah, you can reduce that and it would be the same thing as 1/3, which we already have that. So we don't need 2 over 6. Again, you want to make sure you're not getting any doubles because sometimes fractions can look different but mean the same thing, or they can look the same and mean different things. Okay, so what do we get? We got that one, 3 over 6. That's going to be a half. 4 over, I forgot where we were. I feel like we already did this one here. That'd be 2 over 3. That'd be a 1, and that would be a 2. So actually, we didn't get a whole lot of extra factors from our list. So that's the complete list. So we got about let's see, 12, 24. We got 24 possible zeros that we could use. So, yep, that's a lot of zeros, 24 possible zeros. Okay. All right. So again, we've got to make sure not to get any duplicates and make sure not to get any of them that are going to be the same. So let's go ahead and move on over to the next one. So last number is 24. So think of all the numbers that multiply to 24. So 4 times 6, 3 times 8, 2 times 12, and 1 times 24. So we got a lot of numbers, okay? Got quite a lot of numbers there. And then our first number, so the first term in our case here would be 2. And we need to include all the numbers that you can multiply to get 2, which is 1 and 2. Okay, so it's a small number, but we still got a few of them we got to watch out for. Okay, now we're going to do all the numbers over 1, which is going to be the plus and minus of all the numbers that we have here of 1 through 24. All right, so that's all the, let me get that fixed there. Okay, so now that's all of the whole numbers, all of the numbers over 1, because again, anything divided by 1 is just going to be that same number. Dividing things by 1 does not change anything. Okay, now we got to go through and make sure we get all of the numbers divided by 2. All right, so let's get that 1 over 2. And again, just make sure you don't have any of these. I'm pretty sure we don't have that one. 2 over 2. That would just be the same as 1, so we don't need to put that down. 3 over 2. All right, we don't have a 3 over 2, so let's go ahead and add that to the list. 4 over 2, 6 over 2, 8 over 2, 12 over... Well, it's just going to be half of all those numbers, so half of that would be 2, 3, 4, 6, and 12, which we already have those on the list. They're already on the list that we had before, so just to kind of keep things moving along, I am going to go ahead and call this list complete. There you go. There you go. All righty. So there you go. That's how you find out what kind of factors you can divide out of a polynomial. All right, so when are you going to use this? How would you use this sort of thing? So yeah, the other day I was talking about like keys, right? If somebody gives you a key and says, hey, this key is to my car or that door over there, assuming they know what they're talking about, it should work out. But let's change the story a little bit, okay? Let's say that, I don't know, a janitor's busy or he's having a small emergency of some kind, and he says, hey, I need you to open that door over there. And he gives you his big old, whatever, clump of keys that he has. So it's not the same. It's not like he says, this is the one key to that one door. So we got to find this ourselves. So just like that, you're going to have to try one. And if it doesn't work, try a different key, move it to the next one. If that one doesn't work, same thing. Just keep repeating that process until you get it. So that's kind of what this is like here. List the possible rational zeros using the rational zero theorem. That's what we just did. That's this whole process here of finding out what numbers we can use. Testing the zeros using synthetic substitution. So that's more of what we did yesterday. Okay, like thinking about what we did yesterday, right? But in that one, they gave you the factor, so it should have worked. We should get no remainder. In this one, we have to be a little bit more vigilant because if we make a mistake, we could call the right answer the wrong answer, the wrong answer the right answer. So again, we're just going to go ahead and substitute. Let's go ahead and move on to the next step. That would be to, when you find one that works, okay, so one of them should work out. When you get a remainder of 0, use that to completely factor the polynomial. So we're going to keep going until all of them are separated, and then we find all of the zeros, okay? So that's basically what we're going to do here. So make sure you read the directions, okay? Because you are graded on how well you follow the directions. So the direction says to list the possible rational zeros and then find the actual zero. So again, left, last over first. So all of the numbers that multiply to our last number, 8. So 1 times 8 and 2 times 4. So we only have 4 numbers that can multiply to that. And our first number is going to be 1. So I'm going to put 1 down here. That means we're not going to have any fractions. Well, we're not likely to have any fractions. All right, possible. So we got to write down, because it says, list the possible numbers. So we're going to say that these are the possible numbers. And we're just going to get these 4 numbers with a plus and a minus, because we don't know what they could be. Okay, they could be the plus number, they could be the minus number of that one. And it doesn't give us a factor. It doesn't say given this factor or anything like that. So we're going to have to just try it out. Just try it out. So 1. Just start with their lowest number. Just work from the lowest to the highest, which is a little bit backwards. But again, I guess it's left to right. So just start left to right. And let's start with 1. Okay, now check your numbers, 3, 2, 1, 0, right? All our powers are in order and we're not missing any. So let's go ahead and take the numbers in front of all of our variables, all our coefficients. And we're just going to go ahead and divide them. Now, I don't want this to take too long. All right, we've been doing this for like 2 weeks now. Okay, this is like the 5th or so lesson that we've gotten with this. So I'm going to go a little bit faster. Hopefully that means I don't make any mistakes, because sometimes you got to lose a little bit of focus when you're doing that. But in this case here, if we try using synthetic division, it comes out with a remainder of -10, which again, that's not factorable. That means we cannot divide by 1. So we tried one of the keys, turned it, didn't work. Door's not opening. So we're going to go ahead and move on to the next key, and that's going to be this -1. And your luck is generally better if you try from the low side and work your way up. I'll kind of explain why in a minute, but let's get some of these examples out of the way. But again, you're going to have much better luck if you start from the bottom and work your way up. Okay, so let's go ahead and get this one here. So bring that number down, multiply it by the number in the window. That one too, same thing. -8 times -1, that would make it positive. And this one does work out, okay? Now, just like a janitor's key, well, I don't know how it works, and I wouldn't want to bother them by asking, because they're gonna be like, why are you so concerned about how my keys work? But I think some of them, one key can open multiple doors, okay? So here we have, well, 8 keys, 8 possible outcomes, but 3 of them will work, all right? So again, one key can open multiple doors. I know they have that. I know they call it like a master key. Okay. Now we're going to do what we did yesterday, and we're going to put the x's back in. So here we have our numbers here. We're going to put our x's back in. So again, drop it by 1 power. It's a 3 power. Now it's a 2 power, because we took one of the x's out. And now we're going to put the rest of the x's back in. Okay. All right, now we're going to find the rest of them. So usually when a key works, right? I mean, like, well, if you look at, if you have a couple of keys, right? Like some of them will obviously work like a car key, right? They're usually fancy and plastic. Then you have house keys that usually have, like, I don't know, the top usually looks like a house. And then, I don't know, you could probably tell this is like a warehouse key. You could probably tell like something like this is a cabinet key, right? So they open different things. They look different. So you can kind of knock some of these out. So in this example, back to the story with the janitor, we're going to find the other keys that open this same door. And again, they're keys that usually look alike. So I'm going to just use normal factoring. I'm just going to use life method here. Look at our last number. If you forgot life method, last number here. So I need 2 numbers that multiply to -8, which means one of them is a negative. And that means we're subtracting to get our middle number, our OI. So 4 times 2, that's going to be 8. And 4 minus 2 is going to be 2. So that should work out. And there you go. So we got the whole thing all factored out. Again, very simple factoring. We've been factoring since like September. So if you haven't learned how to factor by now, I don't know what you've been doing with all your time. Hate to say it like that, but it's true. All right, next part here, let's take our factors and we're going to take them out and put them into our solution set, into our zeros. Start with your lowest number. And again, remember, they're opposite. So 4 becomes -4. 1 will become -1. And our -2 will become +2. All right, we shouldn't have that many more to go. I think there's like 10-ish problems. So yeah. All right. So, but some of these are going to take a little bit longer than others. All right, moving on to the next one. Oh, by the way, before I move on, all of these are also, all of our solutions, all our zeros, those are going to be included in our possible list. So 1, 2, and 4 are also going to be on this list here as well. So let's go ahead and move on over to, oh gosh. Oh, well, no, I don't. I didn't even know she was missing them. I thought she came back. Oh, yeah, I don't know. I saw her earlier today, so I don't know if she's still here. Right. I should put something here. All right. Where were we? Oh yeah, listing the possible zeros. All right, so again, last over first. So let's think of all the numbers that multiply to 20. Oops, almost put the times thingy in there. 4 times 5, 2 times 10, and 1 times 20. All right, our first number is 1, which again means we're probably not going to have any fractions, which is good. Fractions always make things more complicated, which means we're just going to have these, what is that, 6 numbers? We're just going to have these 6 numbers as their plus and their minus. So looking at how many we have. So the last one, we had like 12 possibilities. I don't really remember. No, I think we had like 8. And then there were like 3 of them that would have worked. So that was a little bit less than a 50-50 guess. In this case here, we have 12 and 3 of them. So that's about a 1 in 4 guess. So this means we might be guessing about 4 times before we find the right one. All right, well, we just got to start, right? You got to start somewhere. 3, 2. Ooh, be careful. We're missing a 2 power here. That's why I always go over these steps. Make sure you have all of the terms, and if you're missing any of them, fill it in with a 0. Check your powers, 3, 2, 1, which again, we're missing the 2, so fill it in. All right, let's go ahead and work on this. So 1 times 1, 1 plus 0, 1 times 1, 1 minus 21, and 1 times -20, put it over here. And actually on this one here, we seem to have gotten it on our first guess, right? So just picking up a random key, go up to a random door, turn it. Hey, it works. Sometimes you don't have to guess for very long. But then also sometimes the opposite is true, where you're going to be guessing over and over and over again. But usually your lower numbers are more likely to get you a 0. So that's why you start with the low and then work your way up. I'll talk about that some more, but let's go ahead and get this one. So don't forget your original. We have a 1 here. When you put it into a parenthesis or take it out of a parenthesis, it's going to become the opposite. So if I put 1 into a factor, it's now going to become -1. So x minus 1. Then let's go ahead and get these numbers over here, and we're going to put the x's back onto them. All right, and then we're just going to go ahead and do our best to factor this. All right, so this one stays the same. I'm going to factor this. So I need two numbers that multiply to 20. Well, actually negative 20, which again, the signs will matter. The signs do matter because a positive times a negative is how you get a negative. Now, I need these same numbers that multiply to 20. If I minus one from the other, I get 1. What numbers could those be? All right, well, we also have a factor list right here, 4 and 5, right? Because I said one of them minus the other is going to be 1. So 5 minus 4 is 1. 5 minus 4, and that's going to give us a 1 there. Split this up. And there we go. So we got 3 degree, 3 factors, and that means we should have 3 zeros. So negative 5. Well, actually, there'd be 1 next, and then 4. Because again, when you take them out, they're going to be opposite. So 5 to negative 5, negative 1 to positive 1, and negative 4 to 4. And there you go. We got all 3 of them. Now, could you try guessing with like 4 or 5 as your first one? Yeah, but you're not really likely to guess it. And the reason why, all right, so think about what it means. So we're done with this problem here. You don't need to graph it. But just to kind of give you an idea of what the graph would look like. So we've been graphing a lot of polynomials lately, right? We had power functions. Think about all the power functions you looked at. All right, so it would look something like this. You would have a kind of an n-shaped function because that's what the 3 power does. It would cross at negative 5, at 1, and 4. And this is just a rough sketch of the graph. It's probably not what it's actually going to look like. I'd imagine some of these would be much higher and lower than the other ones. But your graphs are usually going to kind of hang around the middle. All right, so that's just kind of just something that happens with polynomial graphs. Okay, so moving on to the next one, let's get the first step, and that is to get our last number factored. So 1 times 18, 2 times 9, 3 times 6. 18 cannot be divided by 4 or 5, so we're going to skip it, and that goes back to 6. So that means we have all of the factors. And again, if you want to, you can draw a list of factors if you want. Our first number here is 1, which again means we're not going to have any remainders. Remainders. We're not going to have any fractions. Ooh, so much vocabulary. Okay, so it's just going to be the positive and the negatives of each of these. So possible numbers, 1, 2, 3, 6, 9, and 18. So those are all the possible numbers. And again, anything we get should be on this list. If you finish your finding zeros and you find out one of the zeros is not on this list, then it's probably wrong. You either missed it in the possibilities, or you probably did something wrong to get a fraction when you shouldn't have, or something that's not on the list. Okay, but you don't, I wouldn't imagine very many people would be checking that to see if they got it right or wrong. Okay, so we got our possible numbers lined up. Let's just start at the bottom. 1 here. So 4, 3, 2, 1, 0. So all of them are there. We shouldn't have to fill in any zeros. Oopsie. Probably wouldn't have made much of a difference, but All right. So again, we've got to be a little bit sure that we did this right. Because again, the remainder tells us whether it's going to work or not. So this one here does not work. So no good. Try the next one. So again, just like a big bundle of keys, you got to try the next key. But like I also said, they kind of hang around near the middle of the axis, which means that you are more likely to get a right answer if you start by the bottom, like better than say like a guess or anything like that. Positive 18. All right, there you go. So again, kind of going through it a little bit quicker. I mean, I'm sure you'd get bored if I had to keep explaining this to you over and over, even though we spent a lot of November working on this sort of thing. All right. Well, we have four terms in this case. Four terms. So if you got space, you can write it down here. And this is just usually the way I do it. Oopsie. So four terms. What we want to do is we want to check to see if we can use factor by grouping. Now, I usually do this off to the side because you can kind of tell. So again, group it, but you also want to make sure you don't have a minus in the middle. So when I put the groups in, yeah, there is going to be a minus in the middle, and we don't want that. So I'm going to scoot them apart a little bit and put the plus in there. Okay, now we've done factor by grouping, right? So they're bringing out all their usual tricks. Factor using life method, factor using AC method, GCF, and in this case here, factor by grouping, which they can also use difference in squares, which actually I think this is going to end up with a difference in squares. So we're going to take out two x's from the first group. And then from this one here, we have a negative, negative, but we don't want them to be negative. We're going to end up making them, oh, sorry. We want them to be positive. So these are two positives, two negatives. So if we take out a negative 9, what is that going to leave in both of these bubbles? So we took out two x's from here. So that's going to be 1x plus 2. X plus 2. And I should get the same thing here if I take out negative 9. So divide both of these by negative 9. X, and it's going to be reversed, so plus 2. So yeah, they both come out to x plus 2. Make sure you do a degree check. 4 power, 1, 2, 3, 4. Don't put any extras in there because that's another common thing that happens, especially when factor by grouping. People think, oh, there's 2 parentheses, so I need to have 2 of those same things. Okay, and I just said that we might also have a difference in squares, and there it is right there, difference in squares. So I'm going to leave this first one the same. And then I'm going to split this one here, x plus 3, x minus 3. Oh yeah, and we got our last one here too, x plus 2. Don't forget any of those. Don't leave them out, especially the first one. Don't leave the first one or anything that they give you. I know when you have givens, it's a lot easier to be like, oh, well, I don't need to put that in there because I didn't work to find it. But there we go. So now we have our 4 solutions. Let's go ahead and put them into our set builder notation. Again, it's going to be opposite. So starting from that would be negative 3. And again, when you put them back in, it's also going to be opposite. So it's negative 1, but when we put it back in, it's going to be positive 1. So it's going to switch when you take them out or put them in. Negative 2. Negative 1, and this one here, this negative here will become our positive 3. Now, I'm going to just draw a rough sketch of the graph because, again, we did graphing power functions before, so should be a little bit easier to tell what's going on. So it's going to cross at negative 3, come back up at negative 2, down at negative 1, probably going to go down a lot lower than that, but it's going to come back at 3. So negative 3, negative 2, negative 1, 3, like I said, a rough sketch. But most graphs, they kind of tend to hang out towards the middle of the graph. So that's why you're more likely to guess. So we're kind of lucky because our second guess has always seemed to be the one that works. Or sometimes you can get it on the first one. Like I think we did have one of them where it did work the first time. Okay, last one. Let's go ahead and get our last number here. So we got 6. So think of all the numbers that multiply to 6. So 1 times 6 and 2 times 3. Think of all the numbers that multiply to 2. So 1 times 2. Those are the only 2 numbers that we have. We don't have more than that. Okay, so for the first one, all four numbers over 1, which just means the whole number of each of those. So 1, 2, 3, and 6. All right, but don't forget, we also have a second bottom number. The second bottom number would be 2. So we have to think of all the numbers over 2. So again, we don't want any duplicates. 1 over 2. Okay, we don't have that, not on the list, so let's add it on. 2 over 2. Yeah, we got one of those. It's just the same thing as 1, so I don't need one of those. And 3 over 2. Well, 6 over 2, maybe. No, that one's not going to work because that's the same as 3, which, again, we already got 3 on the list, so I'm not going to put that on there. So we have about 12 possibilities. And there's 3 keys that work. So about a 1 in 4 chance. So again, we're probably not going to have to guess 4 times in order to get it, just because, like I was saying, graphs usually hang out near the middle. So let's go ahead and get this 3, 2, 1, 0. So they're all there. And just try it out. Alrighty, so in this case here, this one does not work. Yep, doesn't look like it works. So nope. Try the next one. Same thing. All right, there you go. Now that one works. That one works out. So we got it. It should just be a trinomial, but in this case here, it's going to be a 2x squared. So that means we're probably going to have to use AC method, which shouldn't be a big deal. If you want a quick review on AC method, 2 times 6, that would be, actually, I forgot the little square there. But yeah, we're putting the x's back on, and that's going to make it 6 times 2. And I'm just going to factor it again. If you know how to do this, without writing it off to the side, that works too, but I just don't want to skip any steps. So 2 numbers that multiply to 12, but add up to 7. Right? So 3 and -3, -4, they add up to -7, but negative times negative is positive. 3 times 4 is 12. But you also got to take back that number. So in this case here, we got to put the 2 on the bottom here. Now I'm going to rewrite these in the bubbles. Again, if you want to keep your sheet nice and clean, you can also just kind of write the fractions so that they fit in a little bit better here. So 4 over 2 would be, well, 4 divided by 2, right? We've been doing a lot of fraction dividing in this one here. So 4 over 2 would be 2. And there you go. So 3 power, 3 factors, and we should get our 3 solutions from this. Sometimes you will get a double solution with multiplicity, as they call it, which just basically means the same thing 2 or 3 times. But in this case here, I think they're kind of making sure that you know which ones are which. So again, take them out. They become opposite.
Excuse the interruption. We have a couple announcements today. There's going to be no late activity bus for Monavi and Old Airport Road. Again, there's no late activity bus for Monavi and Old Airport Road. Today is tutoring. Student athletes, make sure that you attend tutoring. Girls basketball JV team, you're going to be eating in the cafeteria for tutoring today. Boys varsity, you will be practicing at the elementary school today after tutoring. Ingenuity lab